Good morning, everybody, and welcome to today's webinar. I'm Giulio Poggiaroni from ETA Florence, and today I will be your moderator in this webinar dedicated to critical raw materials, European legislations, and projects aimed at addressing the several issues connected to this topic. So, critical raw materials are, as I said, a hot topic today, which is the result of the I would argue two things: the reality check we were all subject to after the COVID pandemic, where we realized that Europe is reliant on imports, very reliant on imports from abroad, and on the other side, the increase of demand for green technologies and the projected high increase of demand for specific materials and technologies, given the transition towards a more green economy. So this is a change we are seeing, and last year, in March 2023, the European Commission responded with the proposal for a new regulation, the Critical Raw Materials Act, and we saw the debate going on for the whole year. And in the fall of last year, there was the formal adoption. Well, better to say the final vote of the European Parliament, the agreement between the European Parliament and the Council. And the Parliament actually adopted the new legislation in December, and we are just expecting the formal adoption by the Council, which should come early. And so very soon this legislation will come into effect. So now I will give the floor to the first speaker, Daniel Choss from the European Commission, who will talk to us about this new regulation, the objectives, the measures implemented and to be implemented, and the next steps. One last thing from my side, some housekeeping rules. There is the Q&A section be on the bottom bar. Please use this to type in your questions. I will select one or two questions at the end of each presentation, and I will direct this to the speakers, and then there will be dedicated Q&A part towards the end of the webinar. So enough from my side. Daniel, the floor is yours.
Thank you very much, Giulio. Thank you for the invitation, and good morning, everyone. I heard it's a lot of participants, around 300, so I'm really pleased to be here with you to share our insight on the Act and also participate in this meeting hosted by our Horizon Europe Research Innovation projects on raw materials, the Resilex and Resilience. I'm very happy that you cooperate and organize joint events. It's important for us to see that projects also cooperate and work together on various initiatives. On my side, to introduce myself, I work in DG Grow in the unit for energy intensive industries, raw materials and hydrogen. I'm responsible mainly for Horizon Europe programming of R&I calls for proposals on raw materials, but I'm also involved in the critical raw materials list, in the critical raw materials act. So these are the main things we are doing in the unit. I will share you some information about the Act, also and more generally on our raw materials policy, and also a bit about our Horizon Europe funding on raw materials. So as Giulio mentioned in his introduction, due to the COVID pandemic, due to the Russian invasion of Ukraine, and also due to the green and digital transition, the awareness about the role of raw materials, critical raw materials, has increased heavily. You can read about it in the news. You hear politicians talking about it quite often, and you see many reports and various think tanks also writing about it. So basically, everybody knows, everybody is aware, or at least many institutions are aware of the need of critical raw materials. we in the Commission, we are monitoring this since at least 2011 when we started the critical raw materials list. Since 2020, we are also doing forecast studies on the demand of critical raw materials for different technologies and sectors. And here you can see on the left side results of our forecast in 2023 with the data on all raw materials forecasted globally. We see significant increase in demand for various raw materials. Here we just put four: lithium, graphite, cobalt, and nickel, which you can find, for instance, in batteries. So on the one side, we see a very huge increase of demand for raw material side, which causes a question how we can secure a sustainable supply of raw materials to Europe for the technologies that are strategic for the green and digital transition. And so on the one side, we have the growing demand. On the other side, we have our intention to develop strategic technologies that we need. But there is also another gap we see when we look at the full value chain, that if, for instance, we want to develop wind turbines, we are fully dependent in the supply chain, looking backwards on permanent magnets, on rare earth metals, on processing of rare earths, and mining of rare earths. So this is just one example, but on many applications, when we look back to the raw materials, we are very dependent on the third country sourcing of to have the technology ready. So this is the reason why we are looking at the Critical Raw Materials Act as a solution to secure sustainable sourcing of raw materials. And I mentioned the demand increase, and since the Two Horizon projects focus primarily on silicon and rare earths, so here is also some data from the same forecast we did in 2023. So we see the demand in two scenarios, 2030, 2050, in particularly in neodymium and dysprosium, the two rare earths. The demand will grow significantly. For silicon, maybe not that much, but still almost twice the demand in 2030. It's really a lot. So we really need to concentrate our efforts in securing supply of these raw materials. And the Critical Raw Materials Act is a tool that we have developed. And as Julia said in the beginning, we are at the really last stage of having the act adopted. So we are looking with the act with four elements on strengthening the value chain of critical raw materials in Europe, from exploration, extraction, processing, refining, and recycling. We are looking at diversifying the sourcing of critical raw materials for third countries. We are looking at improving the capacity of monitoring and mitigating risks of supply of critical raw materials. So to having better data and better forecasts and better awareness of the situation. And also we're looking at improving the circularity and sustainability of raw materials sourcing. So very basic thing with the act, we had already before the critical raw materials since 2011. Now the methodology of calculating it has been put into the annex of the Critical Raw Materials Act, so it will be part of the official EU legislation. We calculate the list with two factors: supply risk and then the economic importance of a raw material to the EU economy, and based on that we calculate the critical raw material. And with the act, we have introduced a sub-list, a subset of the critical raw materials. So additionally to being critical, these raw materials, the strategic raw materials, are the ones that are important when we look forward for the strategic technologies for the green, digital, defense, and space, and where we see a forecasted demand risk in the future. So the critical raw materials list is more backward looking with the data analysis, while those strategic raw materials, they're more forward looking in what would be important in next year and where we should put particular focus already now in order to mitigate any risks for the future. To help us navigate, we have set different benchmarks for 2030, where we want to be in the supply security of strategic raw material. And we have defined for various stages at the value chain. So for extraction capacity, we want at least 10% of the strategic raw materials consumed in Europe to be extracted domestically in the EU. For processing, we are looking at least at 40%. And for recycling, we look at 25% of the consumption. And additionally, we are also looking for diversifying the sourcing of strategic raw materials to be not higher than 65% from one single country. And I will show you a map on the next slides how this reflects. On the strategic and critical raw materials, here you have the full list. These are critical raw materials, 34 raw materials, and those in green. Additionally, there are also strategic raw materials. So as you can see, silicon and rare earths, they are critical and strategic both. So this is the current list 2023 edition, let's say, because we do the list every 3 years. So the next one is forecasted to be in 2026. I mentioned the global dependencies. So this is the map where we source our critical raw materials from. These are the biggest suppliers with the percentage next to them. So you see we're sourcing all around the world with high quantities from different countries, up to 100% for heavy rare earths, quite often 90%, 80% from different countries. So we are looking here exactly to decrease these figures to 65% the most. We have also capacity in Europe for producing critical raw materials. So when I mentioned the benchmarks for extraction and processing capacity, we look at increasing the existing capacity and possible capacity in the future. So here we have a map of what is already being sourced in Europe from domestic sources. So we'll be looking at ways of improving the situation to be more to having more supplies from Europe from these places. On recycling, for some strategic raw materials, we are already there, like aluminum, tungsten, and copper. But for instance, when you look at much more raw materials, we are even at 0 or 1% or 2%. So there is a lot of work in front of us to improve this end of life recycling rate to be 25%. How we will proceed, we want to strengthen the value chain, particularly through having strategic projects for strategic raw materials. And these projects will be in three stages, so the extraction, processing, and recycling, and also for producing substitutes of materials. These projects will apply to the European Commission. The Commission will assess application with the support of a critical raw materials board composed of member states and the European Parliament and the Commission. We will be looking, when assessing these projects, to the contribution of to security of supply of that particular project. We will be looking at their sustainability, so the environmental elements, the cooperation with local communities. So this is very important. We'll of course look at on the technical side, and we also be looking at cross-border benefits for the EU. In the EU, but also social benefits and also benefits for a third country if a project is to be developed in a third country. Now, what it means to be strategic projects. We want to give some benefits for being a strategic project. So we are looking at improving the predictability of permitting processes in the member states. At this point, we know that in many cases, these, particularly for extraction, these permitting process take years and are really unpredictable in terms of the result, but also sometimes in terms of the criteria. So we are looking here at more predictability. The first thing is having a single contact point in a member states for receiving an application. So instead of because there are often different permits and different requirements. So instead of different institutions, the applicant will apply only to one single point, and that institution will then coordinate internally all the required permits. We have put here specific timelines for processing such applications. For extraction, we foresee 27 months, and processing and recycling 15 months. And as mentioned before, we will be looking at the sustainability elements, so we don't decrease any environmental or social standards. So all these things stay the same. We just meant to have more predictability for in the how the process is designed. And we believe this will help investment projects to move and get materialized. And we'll be also looking together with the Critical Raw Materials Board on various incentives and support, financial supports, but also other elements like standardization, skills, and research and innovation funding. Other element with the act, we are looking at improving our monitoring and mitigation capacity. Of course, we will be continuing the critical raw materials assessment. We will be looking on the strategic raw materials assessment, at where we'll be working on the real-time monitoring with trade flows, demand and supply, concentration of supply, and the production on the global level, on the EU level, to enable us to have some kind of early warning system to know where potentially bottlenecks in the near or longer future can appear. And we, of course, introduce stress testing measures and reporting and coordination of strategic stocks in the member states. And we also foresee a voluntary joint purchasing mechanism. To boost our domestic supply of critical and strategic raw materials, we need to build up our knowledge on what we already possess in Europe. So we have introduced national exploration programs to be performed by the member states to improve the geological knowledge that we have, and that will allow then in potential investors to have to assess the geological deposits in case they are economically feasible to move forward as a mining project. So member states will have to perform such national exploration programs for the mineral mapping, for geochemical campaigns, perform geoscientific surveys, and then process the data and make it available. So this is one element. We are looking at free movement of strategic raw materials and the environmental protection. So member states will also need to perform measures on circularity of critical raw materials to increase the reuse, collection, and recycling of critical raw materials, increase use of secondary raw materials in particular in technologies and products. So not only having recycling capacity, but also making sure that it's really used then in the final products. We'll be looking at maximizing the potential from extractive waste, as there is a lot of extractive waste from the past that we realize that possesses a lot of interesting raw materials inside that needs to be monitored, evaluated, and assessed if possible for economic uptake later on. We'll be looking at recognizing certification schemes on the sustainability of raw materials as well, and also we'll be performing other regulatory measures like review of the end of life vehicles directive, or codes in European list of waste, and harmonizing waste management rules. So there's a lot of activities on our side to be performed. And on the governance, I mentioned the Critical Raw Materials Board, chaired by the Commission, composed by the member states and the Commission, and also the European Parliament will have representatives being observers. And the board will help us on assessing the strategic projects and will help us on all the measures here I introduced, and also help us on strategic partnerships with third countries on raw materials that we are currently developing. We have 8, if I remember correctly. Partnerships already signed. These are the countries in blue. So Greenland, Canada, Chile, Argentina, Namibia, Zambia, DRC, Ukraine, and Kazakhstan. And we are currently also negotiating with Norway and Australia. On the next steps for the implementation, we are at the very last stage of having the act formally adopted by the co-legislators. So this should happen very soon. On our side, we are working on setting up a governance and monitoring mechanism. We are working on setting up the critical raw materials board, and we are also uh, thinking and implementing measures to have a system for receiving the strategic projects and then evaluating them. So this is something which is happening. On the other side, on the RNI funding for raw materials, as you know, the calls for 2024 are still open. For 2025, we will adopt the strategic plan in March, and afterwards we will start working on the calls for proposals for 2025. So you can expect also calls for raw materials there. And otherwise, we are also looking on financial measures that could support strategic projects through the innovation fund or through EIT funded opportunities. Actually, yesterday in Davos, EIT in energy announced a fund for battery raw materials. So that's something that we'll be looking at. And also, we will launch a raw materials academy for skills development. Thank you. And I also have a shortly on Horizon Europe. We still have calls for proposals open till 7th of February this year. So there's little time just to say we have calls for exploration, for processing and refining. We have dedicated calls for rare earths, for due diligence, and we have a call for extraction and processing dedicated to Canada and Ukraine particularly. So this is the offer we have for this year. And very generally speaking, we always cover the area of exploration, extraction, processing, refining, recycling. So you can expect this to come in the next years in 2025, but also the later years of Horizon Europe 26, 27. So this is roughly the situation there. And yeah, I think that's all I wanted to say from my side. And I'm open to questions and for the discussion laterwards. So thank you very much.
Thank you very much, Daniel. Actually, we already have a bunch of questions, and maybe some of them can be answered right now quickly, and then some others will be addressed later, since we have some spare minutes. So the first one, which I think the answer is quite.
Sorry, Julio, just a question from my side.
Yeah.
Am I still sharing my screen or not? Because I don't see the
No.
option.
That's fine. That's fine.
Okay.
So this actually has perhaps a quite easy answer. Would European Commission consider silicon recycling in Europe as a strategic project? And if yes, would there be any funding potential support?
Okay. Well, any strategic, we will of course look at the application, but any strategic raw material that is, we will welcome the applications. We will review them based on the criteria I mentioned and that are based in the Act. And recycling is one of the 3 areas that are possible for the strategic projects. So I think we definitely welcome silicon recycling projects. So yes, definitely. And
Okay.
in terms of the funding, I understand it's a very important question. So we are working on this,
Mhm.
on identifying
Yeah.
options and introducing some measures. But this is too early to give concrete answer.
And actually, there are 2 questions on attached to this. Would be silicon recycle, the silicon recycle, the recycling also applies to, for instance, solar panels produced in China, installed in Europe, which have come at the end of their life cycle. So this also falls within this scope. If we are recycling solar panels which are already in Europe, this could be included, right?
Yes, if it well, it needs to contribute to sorry for this. Basically, yes, if you recycle silicon from products like solar panels in Europe, then I think definitely that's something that improves our
Okay.
security of supply of raw materials.
Okay. And then there was a question about yeah, this perhaps is a big question about the social acceptance, because we know, especially regarding extraction and mining, there are already some strong opposition from local communities. So this remains an issue. And what is your take on this? There would be further measures, or this is something that we only can address through education and compensating for the disadvantages that might cause?
Well, I think well, it's a very important issue for us, the social acceptance and the communication with the local communities. That's very important for us. So we also put that into the criteria for the strategic projects, that we will look at this, how the projects tackle this issue. It's important to communicate transparently with the local communities, with the people that will be directly affected by having a project there. So I think it's very important to share the best practices from various areas, to share the expertise both between companies but also on the public institutions as well, researchers. So there's a lot of room for research actually to explore how to communicate properly, transparently, and giving full information to the citizens that are concerned by these projects. So there's a lot
Mhm.
of to be done by education as well. And yeah, I think
Okay.
we will
Okay.
be supportive to this.
Okay, one last thing that I think might wrap some of the questions received, then we will address the others towards the end. So the strategic project, the framework for selecting the strategic project, the rules, the requirements. So this is something already in the Critical Raw Materials Act, or there will be some need for further, other regulations or delegated regulations from the European Commission?
Well, the act is quite clear. It mentions there the criteria on which we will evaluate. So that will be the basis for us
Okay.
taking the decision. And of course, it also matters how the projects present themselves, how they justify, how they show, quantify the data, how accurate they are. And so we will be assessing these, but it's also an effort to present it in a complex way that, yeah.
Okay, thank you. I think that so we encourage the people who are watching us to get the final version of the Critical Raw Materials Act and check it thoroughly. Then if we don't manage to answer all the questions, I would already anticipate that maybe we can address this to Daniel, and we can post the written reply in the websites of Resilex and Resilience once we will publish the recording and also the presentations. So thank you very much, Daniel. And now I will give the floor to Santiago Cuesta Lopez, who's the coordinator of the Resilex project, the one also I'm working for. Santiago, if you could also switch on the camera and start and also open the microphone. We see your presentation, yeah? And
Now you can
so,
see me and hear. Hello.
fantastic.
Good
Yeah, we
morning,
hear you.
everyone.
So the floor is yours.
Thank you very much, Julio. Good morning, everyone. My name is Santiago Cuesta. As Julio quickly introduced me, I am the general manager of the Iberia Sustainable Mining Cluster, and also I have also the directorship of the Canfield Foundation, which is a small technological center and innovation procurement foundation, working particularly among circular economy, energy, materials, but also in raw materials, no? In Castilla y León region in Spain. Today, I am presenting as director of the Very Sustainable Mining Cluster within the project Resilex, and also some of the activities that we are carrying out, very general, but also quite related to Resilex objectives. Resilex is a project that is coordinated by the Very Sustainable Mining Cluster, but effectively is coordinated by my colleague, Francisco Javier Luque, who is a senior project manager in the office that our cluster, our national association, has in Seville. So the success of the coordination of the project is thanks to our colleague and expert project manager, Francisco. Our cluster is a national association working across the full value chain of raw materials. We have designed this particular association on purpose with the idea of providing a sustainable supply and ensuring the sustainable supply of raw materials to the global European industrial value chains. And because of the importance that in geology has Spain. So our cluster comprises about 80 small and medium enterprises and also big companies in the mining sector, and about 20 organizations, regional governments, other technological centers, and other universities and other actors, no, relevant in the raw materials value chain. And it's important to mention that we are covering the full value chain. And this is the spirit that we have transmitted, as you will see very soon in my presentation, to Resilex project. Because we are working in exploration, we are working in mining, traditional mining, but also but with a big focus on sustainable mining, sustainable technologies, advanced technologies to refine raw materials, not only the production in the mines, but also at the level of the tailings, extraction, industrial symbiosis, etc., etc. And we are also making a strong relevance to the social license to operate, to the interregional and regional value, because as you will see in my presentation also very soon, raw materials are regional and endogenous resources. And we are also preventing recycling of the raw materials and the generation of byproducts, using, for instance, the mining waste as a new product to supply our economy and to reinforce several value chains. Again, this is another factor that leads us to promote and to boost Resilex, the use of mining waste and the recycling of raw materials to be interested again in the key industrial European value chains. So it's also very important to mention, since Daniel very effectively has commented about the Critical Raw Materials Act, that the companies that are embedded in our cluster are securing deposits or tailings of more than 17 critical raw materials or important materials that are mentioned in the Raw Materials Act. So all of this in the Iberian Peninsula, in Spain, and also in the border with Portugal, because we have companies that are part of our cluster that has operation facilities both in Portugal and Spain at the same time. Very important that we have a strong activity in the promotion of innovation. We have currently running about 9 European projects and a collection also of projects from the EIT raw materials and from our national. So as Daniel perfectly introduced the Critical Raw Materials Act, I always want to go to a little bit history. You know, we started a long time ago with the Critical Raw Materials studies and necessity. Our activity started since 2014, where I started also as representative in the operational groups in the EIP on raw materials. So it started with the European Innovation Partnership on raw materials, and now has ended into the Critical Raw Materials Act. So it's more than about 10 years of working of the European Commission and the different member states to really secure the sustainable supply of raw materials and to really address the problems that we are having of supply and dependency in the raw materials in Europe. I think there are important milestones, like the Commissioner Thierry Breton communication on September 3rd of 2020 about the importance of the resilience of the European value chains and the relevance that the critical raw materials have. and also the creation of ERMA by DIT Raw Materials. And why I'm explaining all that, and I will not enter into the details of the Critical Raw Materials Act because Daniel perfectly commented, but I am saying that because, as you will see, Resilex is somehow, even if it was created before or conceived before the Critical Raw Materials Act was launched, Resilex is giving an important step in at least 3 of the key objectives that the Critical Raw Materials Act has. Resilex, as you will see, is innovating processing technologies and also refinement technologies, and the creation also of value chains for recycling raw materials from the mining waste and also from the spent use of solar photovoltaic panels. So at the end, projects like Resilex are fitting the objectives and are fitting the spirit that or at least the technical spirit, because the Critical Raw Materials Act has different goals, even transversal, as Daniel mentioned, but it is a key project that is addressing some of the main milestones that the European Critical Raw Materials Act is putting as goals. As I was mentioning, we are playing an important activity in the regions of Europe, in the Smart Specialization Platform and in the different strategic industrial groups and platforms that we have created. And I am not saying this just for publicity, I am saying this because understanding the role of the regions and understanding the importance that the local permits, the social license to operate, and the local investment and the local use of policy plus investment, this is very important to launch and to make any project viable after European funding and to attract industry and to really make real this boost of promoting the Critical Raw Materials Act, as well as projects like Resilex. In Resilex, we are taking this into account because, as you will see, Resilex is playing also, or is taking care of the batteries value chain. Not in vain, I am the responsible within the Smart Specialization Platform of batteries and recycling batteries. I am the responsible, and our cluster and our technological center are actively participating on this, on the taking care of the sustainable supply strategy of minerals and raw materials related to the batteries value chain for Europe. And this is done further interregional funding activities and also ERDF regional funding activities. Of relevance, not only the SDP advanced platform of advanced materials for batteries, but also the mining region industry. You know? We have also created this platform to really make true the real supply of raw materials. Daniel explained it very precisely what is going on under DG Grow and under the normal Horizon Europe goals, but I have just to give you the food for thought of the importance of the interregional and regional DG Regio goals, because at the end, the synergy between the two funds are really the key to the success of making a project viable and generating investments by the creation of regional ecosystems. This is one of the objectives of the SDP Mining Industry Partnership, which is coordinated by the Lapland government in Finland, by Kristiina Jokalainen and the governor Mika Ripi, and Business Joensuu with Ilkka Ninkanen. And our region, together with the region Andalusia, where our cluster is also present, we have played an important role in the design of all the objectives of the platform. And this is how Resilex, at the end, was given light, was born. As you can see, Resilex is joining a collection of industries and small and medium enterprises, bringing companies from our cluster, companies of relevance like is mining, which are working, is a mining company in Andalusia region, and also mining companies like Gesmille in Castilla y León, Pasek in Asturias region, etc., etc. Plus highly technological companies and RTOs like CA, NTNU, Brunel University, Ghent University, etc., 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 plus the importance of clusters. If you take a look on partners in Resilex, it is perfectly referring the quadruple helix, which is mentioned in the Smart Specialization Strategy and in the S3P activities of the Regio, plus, of course, answering to the requirements of the part Resilex was addressing. Just to give you a quick view of what we decided to target, no, with the project. The idea of Resilex, again, is also, as I was mentioning, fitted to the Raw Materials Act and fitted to the main, what I like to call the main war horses that the European Commission and the Critical Raw Materials Act is pursuing. Why these four main horses? One is the batteries. We need to make the green transition of the energy. So batteries is one of the key steps and milestones. The permanent magnets is another of the war horses. As Daniel just mentioned in the calls that are open, the creation of a permanent magnets hub. We have created also at interregional level this hub already, and our cluster is one of the relevant actors in permanent magnets at the regional level, interregional European level, and we are for sure proposing something new at European level in these calls. Solar panels and microchips, which are strongly related, and this is Resilex, because of the silicon as one of the main important raw materials involved. And of course, the other workhorse is the catalyzers, no? Catalyzers for the hydrogen production, etc., which are very important or will be very important in this transition. So as you can see, the work packages of Resilex are somehow devoted to the organization, the exploitation, this interregional value declaration, but it's also very important that we will demonstrate 7 technologies in 8 demonstrators. So that comprises about 5 work packages, which at the end are bringing to light important milestones, no? Important milestones of technology. Let me highlight that one of the core objective is to create a sustainable silicon production for Europe. So demonstrate that the supply of silicon for all the European value chains, more important batteries, microchips, and solar photovoltaic production, can be achieved thanks, or can be really improved thanks to the technologies that Resilex is going to demonstrate. Again, to summarize and to highlight the importance of our project, we have summarized the innovations in 3 lines or 3 main axes. First, as I was mentioning, and also very important in the Critical Raw Materials Act, is the critical raw materials extraction and recovery from mining waste. We have discovered that special technologies that we are developing in Resilex can be applied to different sources and different tailings of mining waste to recover different critical raw materials, from silicon to other important critical raw materials like cobalt. And this is being one of the pilot demonstrations that Resilex is carrying out, with the main objective of recovering silicon, for sure, but also thanks to Spanish companies that I already mentioned that are part of our cluster, we are having a satellite demonstration of future possible exploitation of the technologies developed in Resilex to be applied into the recycling of other critical raw materials of importance in different locations of mining tailings, mining waste in the Iberian Peninsula. The key axis, the axis number 2, will be the recycling or re-extracting silicon from the end-of-life solar panels, in order to really prove that the process is precise enough to produce new ingots and to give again production to wafers and new solar cells. No? So in other words, proving that the circular economy approach or the circularity of the raw materials in the PV value chain is possible. That will change totally the paradigm of the European dependence for this important value chain on renewable energies. And third, the last but not the least, the use of end-of-life solar panels. So we extract the raw materials there, we purify them, and we create new anodes for the batteries value chain. With this line, we are trying to synchronize and synergize and make a real symbiosis of the recycling with the new production of other value chains, so making this industrial symbiosis between different value chains, but quite related because of the renewable energy importance, to really see if the end of life of products can be also used in key products like the production of new batteries. So just to mention how the project is proceeding, because we are more or less in the Ecuador of the project, we are developing new production of silicon alloys, fully compatible with the production of new solar panels. Currently, we are about to undertake the step of creating the metal with expected quality to really prove the technology. We are also producing new panels, as I was mentioning, the axis. And these new panels, we are also targeting, thanks to the advanced technologies developed in the CNRS in France, CA in France, and CSIM. We are producing new panels with a strong reduction of about 70% of input. We have not mentioned this, but this is also part of the activities that the previous raw materials activities of European Commission, since I was mentioning in 2014, and now I think it will be also present somehow in the Critica Raw Materials Act, is about the substitution of critical raw materials. So Resilex is proving, as I was mentioning, not only the recycling of critical raw materials, the supply or sustainable supply of raw materials by extracting from the waste or new processing technologies, but also it's very important to solve the problem of raw materials, reduced use. And Resilex is proving this in the solar panel technologies. As I was mentioning, and I'm very quick because I am consuming my time, the importance of how we are proving, and now we are about to finalizing the last steps for the separation in the pilot line for the recovery of the silicon, and to check if it can be upgraded to the production of solar panel. And also, thanks to MPO from Norway, we are about around the spring of this year, we will demonstrate the high energy density of the anodes for the battery using. And for sure, as I was mentioning already, we are developing this technology to recycling from the mining waste, which is also part of the success of the project. Created an important network. You can join Resilex network and Resilex activity very easily if you just tap resilexproject.eu. We are carrying out, thanks to TIP Photovoltaics, an event in Brussels. We are engaging stakeholders, research centers, because our aim, as I was mentioning, is to also continue and replicate Resilex at interregional level, launch new project tools that the European Commission give to us, like Euroclusters and the ERDF funds, plus the I3 interregional investment funds, as we have been already successful in other raw materials and project applications. Our idea is to also continue with this strategy with Resilex. Thanks to all the project team, the project per se. Thanks a lot to, as I was mentioning, to Francisco Luque for the effective coordination on behalf of our organization, and thanks to all of you for making Resilex possible. Thank you very much. Any kind of contact, and you can write to info Resilex project. You can visit the webpage, and of course, contact our cluster and contact my colleague Francisco. Thank you very much.
Thank you very much, Santiago. Yes, we are we are consuming time, but I guess we can go a little bit beyond the limit we set. So now I would like to give the floor to Carlo Burkhardt from the University of Pforzheim, who's the coordinator of the Resilience project, which is the sister project of Resilex, was funded in the same Horizon call. And we are very happy to start this cooperation together on shared activities with this joint webinar. So Carlo, the floor is yours.
Yeah, thank you very much for giving me the opportunity to present the Resilience project here. My name is Carlo Burkhardt. I'm a professor at Pforzheim University, where I'm heading the Institute for Precious and Technology Metals. So I'm working on permanent magnets since about 30 years. And my PhD thesis, when neodymium iron boron was a replacement for the critical materials samarium and cobalt, and iron was abundant, boron was abundant, and neodymium, nobody knew what to do with it. So it was the idea to have the cheapest magnet that you can ever produce. But we know history contradicted this a bit, and we know now today that the magnetic materials are very critical. And the idea of the Resilience project is to build a sustainable supply chain for magnetic rare earth materials. And well, to start the thing, it's not so easy for us as it is for the battery people or for you with a silicon to get the public awareness, because magnets are considered most of the time a cheap toy for clasps of handbags, for fridge magnets. And a lot of people don't know that it's really that high performance material, and only slowly we're getting through to the public. Here, I'm sure you as an expert, for you it's a bit different, but just to show you, because a lot of time rare earths and magnets are just considered as an equivalent. The magnets are made out of rare earths, iron and boron, and we have two phases. One is a hard magnetic phase, which is neodymium-2 iron 14B. And these are, you can consider them as being individual, very small magnets that are decoupled by a neodymium-rich phase, which is insulating and giving this very high strength. And there are other magnetic materials around, like ferrites, like samarium cobalts, but the substitution is not so easy, because first of all, you can very much align this material, making high performance magnets. And this leads to that motors and generators that have magnets in that are made from neodymium iron boron about 15% more efficient than other magnetic materials. And this translates not only in efficiency, it translates into distance. So you need less battery. For example, in traction cars, but also in all these handheld devices that we have. And it also translates in performance weight, which means that a lot of very lightweight applications, like drones, for example, they wouldn't fly if you would have a normal induction motor or using other magnets. And this leads to a huge variety of magnets that are all around us. As I said, all the handheld tools, electric bikes, drones, but also the loudspeakers in flat screen TVs, in the mobile phones, in actuators that you need for automation, for robotics, for industrial motors, heat pumps. The Eurofighter, for example, has 16,000 magnets in. But the two main drivers that are really putting pressure on the market are new applications like wind turbines, which are used for the green energy conversion, where we have roughly about 650 kilograms per megawatt, which means that huge or large offshore wind turbines have up to 12 or even 15 tons have we seen in largest now that in China. So that's one that puts pressure on the market. And the second is, of course, the electromobility. And 95% of the cars worldwide are using permanent magnet motors. The 5% that are currently on the market, they're avoiding the permanent magnets for the criticality, even knowing that it gives them a lower range and a lower battery performance. And that means that on the list of all materials, the light and the heavy rare earths, so the lights are praseodymium and neodymium, and the heavy rare earths are dysprosium and terbium, are on top of the list of the European Union because they're important for all our key technologies. You see here they mentioned fuel cells, motors, wind turbines, robotics, drones, and also ICT. And as we heard before in the Critical Raw Materials Act, we are here fully dependent on China. We need a European strategy that was first formulated in his action plan of the European Raw Material Alliance, Rare Earths, Magnets and Motor European Call for Action. That means supporting mining projects in Europe and reliable partner countries, supporting strategic investments over the whole value chain. And then in the Critical Raw Material Act, this culminated in some benchmarks. They're not called targets because they are not hard targets, but they're called benchmarks. And it was mentioned before by Daniel, 10% of the EU's annual needs for extraction, 40% in processing done in Europe, and 25% of recycling done in Europe. And these are very ambitious targets because today we have recycling and production rates which are about 1%. So what we do in the Resilience project is exactly reflecting this, and this is meeting the rising demand by securing a resilient and sustainable supply, establishing a circular economy for the magnets through a consistent increase of recycling rates and further developing the technologies needed. Also very important, bringing transparency in the material flow by looking into full traceability, by connecting everything with ESG standards. And also a very important thing, increasing EU production figures by ramping up 3 production sites in Europe. Additionally, developing magnets which enhance functionalities and reduce rare earth content, so that's a research part of it. Creating jobs over the whole supply chain is hopefully coming with all that we are doing. And also for me, one of the key components is developing a concept to educate magnets experts. What's always coming with this project is, of course, dissemination, exploitation, and communication, which is a super important part, especially in a field where, as I said, where the public awareness for the criticality of magnets is not as developed as we magnets people probably would like to wish. So what are we doing? We have let's say, a front end and a back end in our project, and the core of it is developing an alloy generator, and here very much copying what the steel industry is doing by mixing virgin material with secondary material, and to level this out to give you a constant quality in the end with the maximum ESG criteria you can get. And here we're looking into virgin materials from non-Chinese sources, but also alternative sources, which would come from traces of the rare earths in apatite fertilizer sources. And then in the different secondary processes, one of which is the HPMS, I come to that in a bit. Second one, hydrometallurgy and pyrometallurgy, also having door open for others. And we feed this material and the software will know about the ESG criteria, so about the sustainability, about the ethics and governance of this material. We feed it into a alloy generator, which then provides us the best material under this criteria at a certain time to give us an output, a defined magnets quality, which is coming with a chemical composition. Because in the magnets industry, we have one thing that's particularly different than in all the other material fields. Normally, for example, when you buy a steel, you buy a chemical composition, which is giving you a mechanical performance. In magnets, you buy a magnets grade, and the chemical composition can be completely different today, and sometimes can be traced down to the mine where it's coming from. And we want to change that and have a fixed chemical composition, which has different amounts of primary and secondary material in, and then allowing us to ramp up the secondary sources that will come over time when wind turbines, when electric motors are coming back and more material is available, with a constant output on the other side. And the second big part of it is to set up fully automated magnets production here in Europe of course, feeding then their production scrap and grinding slurry back in the loop. The consortium we have is going through the whole value chain from a mine in Malawi with Makango, also operating a refinery in Poland, over recyclers like Carister and Hypermark. Then we have automation people in, we have magnets producers in, and we have the end users to show that it's really relevant. This accompanied by the academia we need to fulfill the research parts of it. So what we've done so far, we mapped the sources. We built a database for primary sources, which currently contains 715 non-Chinese sources. And these sources, first of all, means sites where rare earths are, but it narrows down in the end to what is really processing. And that's, of course, what we are targeting for. On the secondary side, we also build up a database where so far we have over 180 different magnet-containing applications which have been taken apart. We looked for recyclability with the parameters of accessibility, how are they glued in, what coatings are used because they're relevant for our recycling processes. And also here, of course, identifying first of all which are the best sources for the recycling, but also giving important input for automatic dismantling of the interesting sources, and for a design for recycling guide, which we are making to make future products more recyclable. We are also looking into unconventional sources. As I said here, the market is not so easy to get hand on the material. When coming to the recycling, we look into, let's say, both routes. There is one that is long loop, where you go back to the rare earth oxide via hydrometallurgy or pyrometallurgy, and then refine the material again, make a metal out of it, make the neodymium iron boron alloy and the magnet out of it. The advantage here is that these routes can use very mixed scrap and make a very pure oxide out of it. The disadvantage is that all the energy consumption steps like solvent extraction, electrorefining, alloy production, where a lot of energy is needed, and in the solvent extraction also a lot of chemistry is needed, is giving you a not so good environmental footprint compared to the second one, which is called short loop or magnet to magnet or direct recycling, also called HPMS because it's it's a brand name of the University of Birmingham that has an IP on this, which is called hydrogen processing of magnetic scrap. And here the big advantage is that you keep the neodymium boron as an alloy, make a powder out of it that's non-magnetized after this hydrogenation step that is used for this process. And you can make directly out of this powder a new sintered magnet, also via via second steps, not purification, can make melt-spun material or HDDR material for bonded magnets. And here the environmental footprint is much better. And in all the criteria, means water consumption, also CO2, in zero production, we are 90% better than the virgin material. And that's something, for example, what my research group is focusing on. And the process itself is very simple. You introduce hydrogen to the magnet. This hydrogen goes to the grain boundary phases, produces a hydride, which is bigger in volume, and it cracks the material apart. And if the video is hopefully running here, there you can see this for a voice call magnet of a hard disk drive. Of course, the whole process is speeded up. It will take about 45 minutes, but you produce a powder, and the coating that you have on top, the corrosion protection coating, in an ideal case can be sieved off, and you use this material directly to make new material. However, that's only one part of the story, because in the last couple of years in projects, starting in 2011, really, these recycling technologies have been developed and are considered to be quite mature now, but the recycling rate is still about 1%. And this has a couple of reasons that make the circular economy quite tricky. There's a large diversity, first of all, of end-of-life magnets. As I mentioned, samarium cobalt, ferrites, neodymium boron. First of all, they are all silver and shiny. We have no design for recycling. A lot of magnets are glued in. There are coatings on top, which are not very recycling friendly. And we also have underdeveloped recycling schemes because very often material is coming in mixed scrap or is even exported. Then the second big issue is these magnets are highly efficient. And that means in all components, really, the magnet content is very low. In a mobile phone, for example, 4 to 6 grams. So it makes no sense to disassemble the product just for the magnets. It has to be for all the materials. And this is also true for an electric car. If you have a 2 tons car and only 3 to 5 kilograms of magnets, then the recycling, therefore, is depending very much on the accessibility and how you automatically can sort the material. And so today, a lot of the material is just shredded, and this is not really good for recycling. First of all, because the magnets can be only difficult to be extracted, and also the magnets as a hard material, a hard metal, is ruining the shredders. And also this magnet scrap is agglomerating everywhere. So it's very important to get it out of the material, of the process. So what we are developing is automated features. For example, this is a device to extract the magnets from hard disk drives, which come in large quantities from server farms. So that's a prototype. This will be the serial production, very much smaller and very much faster. We are also developing sorting device to distinguish between a neomagnet and a ferrite magnet. And we also made a very comprehensive design for recycling guides with all the ideas we got from which coatings are to be used, which are the best fixations. And here we're working very closely together with tier ones and OEMs to make future products much more recyclable than they are today. We're scaling up production. So this is an aerial of the Tyseley Energy Park in the UK, where a spin-off of the University of Birmingham is ramping up the production first to 200 tons, then to 500 tons. They're a bit ahead of the German enterprise. They also got their presses and the sintering furnace already there. It's currently commissioned. In Germany, we're setting up also as a spin-off of Pforzheim University, a production plant. And here we've just chosen a production site and have just a simulation. So material is coming in that we can set up production, which is supposed to be running next year. We're doing a lot of blending of the materials trials to mix virgin material with recycled material, but also of mixing materials of different quality, like high dysprosium and low dysprosium, to get optimized properties and to feed this in these alloy calculators that I mentioned before. On the scientific side, there is one work package which is looking into how can we make the whole magnets production more sustainable even than today. And at TU Freiberg, they're developing a non-consumable anode for the electrowinning. And this would be a real breakthrough because today the consumable anodes, they produce a lot of toxic gases. And here, this would not be the case, and we would be much more environmentally friendly. Second thing that we're looking into is removing the neodymium trace from the magnets and bringing in low tactic alloys that are lower in rare earth content. So that's also a hot development topic to come to the same or even probably superior properties. And the last bit that I want to show you today is that we're developing with the academic partners a curriculum for a master's degree, which we currently call as a working title, a master's magnets expert, where we will provide all the modules that we think that are important to develop people that have really a thorough understanding of magnets, because magnets are not happening in material science, they're not happening in physics, they're not happening in chemistry. you everywhere get the basics, but you don't get the differences between samarium, cobalt, neodymium, boron, and ferrite, and of course not the specifics that we need, like simulations that reuse recycling, like life cycle assessment. And here we got a enormous feedback from industry about people wanting already to supply topics for master thesis, having placement schemes. And we're currently forming consortium to roll out this in very close cooperation with the EIT Raw Materials, because we want to have a certified degree here to start here to build magnets experts. And that would it be in a nutshell. I was talking very fast because we were already late. If you have questions to us, well, we're on the net, we're on LinkedIn, we're on X, formerly Twitter. You can also send me a mail. And I forgot to mention here, we will also have an event with RIA in Brussels. The Thursday before Easter, we will announce this on our website and in LinkedIn, obviously. So thank you very much for your attention. And I don't know if we have time for questions.
Thank you very much, Carlo. Yeah, I will keep the question for later. Now there is, well, where do you plan to give your rare earth magnets master courses?
Well, we are planning to have 3 entry points: one in the west, one in the east of Europe, and probably 1 or 2 in the middle of Europe.
Okay.
And then we will have a combination of online and offline courses or physical attendance courses. And we're discussing with EIT Raw Materials that we will have a kind of fellowship that the students will get travel money to also travel around. So we try to make it as accessible as possible, and probably have some courses that are given in the east and in the west, and the students can choose which is more convenient.
Fantastic. So I guess you will publish all the informations on this as soon as they come along.
Oh yes, here the devil is in the detail, administration and so on. So it will take another half a year until this is really happening, as that curriculum itself is standing, but the organization is currently underway.
Okay. How many HPMS plants do you envisage there will be in Europe?
Well, there will be in Europe at least 2, one in the UK, which will be the advanced, because it's also funded with national money, as it's a German one. That's the second one. There are definitely plans for a third one in the US, but there may be others in Eastern Europe, for example.
Okay.
So this work in progress.
Fantastic. I would encourage Carlo and Santiago to type in the chat their emails, since I saw some comments were asking for your emails, I guess, to ask more questions and specifics. For the time being, I would like to invite to the floor Marie-Nicole, who's our last speaker from Group COMET. Since we had the 2 presentations from the projects, now we wanted to bring in the point of view of an industry, of a company who's involved in the Resilex project, but way before then it was involved in the recycling of end-of-life panels, solar panels, to extract precious materials. So welcome, Marie, the floor is yours.
Yes. Thank you. I will share my screen. Can you see it?
Yeah, put it full screen mode and then you can start.
Yeah. Okay. So I'm working for COMET. We are a Belgian company active in the recycling industry. We have several entities, mainly COMET Sambre, which operates 2 shredders, including one of the biggest shredder in Europe, the biggest shredder in Europe, sorry, and COMET Traitement, for which I'm working, which started in 2002. And which processes and recovers the shredder residues from our company COMET Sambre. we are essentially active in the mechanical recycling and obviously circular economy. We are one of the biggest suppliers of secondary materials for the steel industry, processing roughly more than 1 million tons a year in waste, and as you can see, at 800,000 tons a year in metallic scraps. Essentially metallic scraps. We have also end-of-life vehicles, household appliances, W3E, and obviously, as the time goes, we have more and more diverse waste streams, like end-of-life panels, PV panels, e-scooters, e-bikes. We have tires also. So for COMET Traitement, we are fast growing. We have a unique expertise in R&D programs. And one of our particularities is that we invest rapidly in the industrial pilots, demonstrators, and plants. And we always see our R&D project through to industrial level. Probably because we are a family-owned company, which is why they can take those risks. For our feedstock, we have lots of feedstock. And you can see many end-of-life vehicles. Here you can see vehicles. I must precise that we have both combustion engines, electric vehicles, hybrid. We also have some hydrogen vehicles, the first we had in Europe. On this picture, you can see a campaign that was done 10 years ago with some Toyota Prius. We have also big vehicles like buses. Those are not the main. Another big stream is the W3E, the household appliances, both big and small. We have plastic waste from the collectivities and toys also. We have recycling centers, metal parts from work sites. And as I said, the diversification for us is towards e-mobility, like as you can see here, scooters and bikes, and also photovoltaic panels, end-of-life photovoltaic panels. We have actually we received them from Belgium and France. Actually, since we are essentially a mechanical recycler first, every stream, every one of our waste streams is sent to the shredder, but some need to be dismantled and or depolluted before. So for the vehicles, we remove the fluids, the tires, because we have also an entity recycling tires, the catalysts, and also obviously the batteries. We could also put it could be variable for us to take other parts, specific parts. But most of those ELVs are already compacted when they arrive at COMET. For the household appliances, they are also dismantled, I must say, by hand. We take the cables, the motherboards, batteries. We have automatic dismantling to take the batteries off. And Before, those batteries were recycled through an external specialized value chain, but we are currently developing our own technologies to recycle them in collaboration with partners. Once those streams went to the shredders, we shred them individually. So we don't mix streams because we don't recover always the same things in them, and there's more value for us into the shredding each stream separately. So after the shredders, we have several treatment processes, including magnetic separation, air separation, and so on. After that, the steel parts are sent to the steel industries. And at COMET treatment, we recover the light and heavy shredder residues that we treat we have special treatment lines, batteries also. And with those lines, we actually can recover minerals and glass that we will use in the technical sand for roads as a substitution to marine sand. We recover foam, wood, all those end products that have no instant value. And we have several R&D projects to add value to those streams, especially with catalytic cracking. Thanks to those R&D projects, we can, as you see, go up to a recycling rate of 97.8% with them. And we always upscale our technologies to pilot and demo and plant level. So briefly for the plastic upcycling, because it's it's not critical raw materials, but it's a big part of what we do. We are able to produce ABS, PS, PP, PE, and filled PP purified to from 96 to 98% of purity. And what you can see here actually is a glove box. It was part of an R&D project, a glove box made for the Fiat 500 with 100% recycled PP from COMET. And another big stream that we recover is obviously the non-ferrous metals, which interest us right now for the critical raw materials. We have developed our own technologies with robotized smart sorting and hydrometallurgy. For example, you can see here for copper, we have a plant which is in the start right now to recover copper from our waste streams at industrial level, obviously. And all those represent actually more than 25 million euros investment in those industrial units in the last 3 years. So as as we are all aware, we have faced several revolutions since the 18th century. Before we would need more like basic elements. But since the Industrial Revolution in the 19th century, the needs have arisen for more and more complex elements. So especially after the automotive revolution, and obviously now with the new technologies and energies, we see the rise in more and more rare earth elements, especially, and the constant growth and increasing complexity of these new technologies. Also, the need for an ecological transition, which is represented in the last revolution, means that we have an increasing need in specific raw materials, especially rare earth, as we said, increasing need in materials that we were already using, but that we need even more, like copper, which have been identified as critical raw material. And those resources are not infinite. Many of them will not last, obviously. And then we need to find other sources like recycling, which is where we are positioned at COMET. And our main goal is to optimize the purification versus the economic value. We obviously face lots of new challenges because new feedstocks mean that we need to adapt more and more to them, and we have also face also an increasing rise in safety challenges, because batteries, as you can see here, batteries in streams can take fire. So that's one of the main issues that we face. And we obviously want to contribute to a more independence of the Europe in critical raw materials by recycling them, recovering and recycling them. For that, we are very active, as I said, in R&D projects, as you can see. They are conducted at regional levels with the Reverse Metallurgy Initiative. We are part of the Circular Wallonia Plan because Wallonia has a strong heritage in metallurgy, obviously, and we always exploit the results to industrial levels. We are also present in European projects like Resilex, and as you can see, those most of those projects are linked to the recovery of critical raw materials. So to resume, because obviously to recover those materials, mechanical dismantling can be the only solution. So for us, everything goes through the mechanical dismantling, sometimes automatized sorting, and then we will get the critical raw materials through refining processes, especially hydrometallurgical process, like the NOVA process and the Resilex process. The Resilex process is the new unit we are currently starting for copper recovery. So we have those are the main feedstock, linked to the critical raw materials, W3E, e-mobility, obviously, As I said, the challenges are changing because we need to have more safety concerning the batteries, obviously. We need to face upcycling challenges because downcycling is not a solution. So we need to be able to have material of enough grade to bypass the smelters. And as you can see, we don't treat only the batteries, but also the polymetallic concentrates from the e-mobility, the magnets. Also, they are extracted mechanically, the rotors, the magnets, and every time the refining process is hydrometallurgical or pyrometallurgical in the case of polymetallic concentrates and precious metals. Then we have the new stream of photovoltaic panels, which are also mechanically dismantled. We can recover the silicon via mechanical sorting, and then for the silver we have obviously a leaching process, and that is all from me.
Thank you very much, Marie. Maybe wait a few seconds to see if there are some questions, but I have one question, one consideration for you. So, so based on your experience and the work done, do you think that the 25% target of recycling of critical raw materials, 25% of the overall consumption needs, do you think it is achievable by 2030? And if yes, what do you think would be the conditions?
We have lots of lots of wastes. But we need to 2030 is tomorrow.
Yeah, true.
So we really need to accelerate. I think, in my opinion, we need to accelerate the research on that, on how to recover well and safely and ecologically. Also, because some of those processes can be ecological, can have some ecological issues. It can be achieved, but we need to put all efforts into that.
Okay. Do you think that there is also well, probably that's the answer yes, but I see that there is plenty of room for improvement regarding the collection. Maybe I started seeing some companies putting their eyes on the end of life panels, so there is a huge business that could be grown in this sector, so looking for exhaust end of life solar panels that can be used for recycling, and this would be a challenge for the next years for sure.
Yes, that's
okay. So that's it for today. I would like to thank you all the speakers that intervened today. Maybe if you want to switch on the camera for a final salute. We are going to publish the recording and all the presentations early next week at the latest. And if you have questions, you can direct them to us via the links, the profiles that we included in the chat. And of course, check the Resilience and Resilex websites to stay updated, and also to forward your questions and take a closer look at the upcoming activities that the both two projects will develop soon. Thanks again to our speakers, and hope to see you here next time. Goodbye to everybody.
Thank you. Goodbye.
Bye-bye.
Thank you.